area approximation with sigma notation. In this portion of the lesson, we're going to relate area approximation, area under a curve, and how we can use sigma notation. So finding the area of each rectangle and adding them together can be tedious, especially as the number of rectangles increases. To simplify, we can use sigma notation. Earlier, we had an example where f of x was equal to 3x plus 2, and there were 6 rectangles under the curve, and we wanted to approximate the area by using the LRAM. And we found out that the summation would be the width of the interval was 0.5, and I should note that in that example, we were on the closed interval 1 to 4. That helps us out find our delta x. You can recall delta x was 4 minus 1, which is 3. 3 divided by 6 is 1/2. So we got the width interval width. And then the vertical length, or the height of each rectangle, was found by f of x evaluated at each interval. So since we have 6 rectangles, we could take 0.5 summation through all of these. Well, we're going to look at how we can rewrite this as a summation to simplify our work. So let's analyze how we took this area approximation and came up with this summation. When we look at the breakdown of the summation, we notice that the first indice, I equals 1, is starting with the first rectangle, and the upper bound 6 is the total number of rectangles. 0.5 is the width of the rectangles, and this formula, I plus 1 divided by 2, is the height of each rectangle, and it comes from these values up here. Let's break this down a little bit further and see how we came up with the sequence of 1, 1.5, and so on comes out of I plus 1 divided by 2. This highlighted part right here, I plus 1 divided by 2, comes from comparing the I values with the actual x values to be substituted into the function. Seeing the pattern, our x values are 1, 3 over 2, 2, and 5 over 2, etc., which would require adding 1 to each I value and then dividing by 2. So for example, when I is equal to 1, I would have 1 plus 1 divided by 2 is equal to 1. That's our first I value. When I is equal to 2, I have 2 plus 1 divided by 2 is equal to 3/2, which was our second I value. And if you continue that pattern, you can see we wind up with these incremental values right here.